Hey everybody, this video is on C++ copy constructors. Copy constructors in object-oriented programming. So what is a copy constructor? Well, we saw previously that we can do a member-wise assignment using the assignment operator. Let's presume that we had created a goat previously, and now we wanted to create another goat and assign it the values of another goat. And we could do this, goat 6 equals, let's say, goat 4. And this does the member-wise assignment. It's just going to copy everything over. Now, I mentioned in the member-wise assignment video that this is fine, but it's limited. This functionality really limits our abilities. One thing is that we couldn't ever use a very popular convention for creating an object based on the template of another object, which would look like this, goat 6, and we're creating that from goat 4. That's a very popular coding convention, and it conforms with just about everything that we've done. You can create a vector based on another vector, an array based on another array. All of these you can do. But with member-wise assignment, you cannot do this. This is impossible. The other problem is that if the goat class contains any dynamic memory, well, then you cannot use member-wise assignment. Let's talk about that real quick. If we had goat A here, and then we had goat B, and then let's say that goat B somewhere in here has, some type of a dynamic memory. Maybe it's a dynamic array of something. Well, if we were to copy all of the contents of object B over to the contents of the new object A, what happens with this pointer is, yep, the pointer itself is also copied over. But that creates a significant security issue. It means that both object A here and object B, they're both pointing to the same dynamic memory that was allocated. So if this is the pointer to it, they're both pointing at the exact same thing. This means that A then, if they're pointing to it, A can go and alter the contents here, or B can go and alter the contents here. And this gives the very disturbing behavior that I've got my object data. I have a reasonable expectation that it's being closely protected, and using the principles of encapsulation and data hiding, I should be fairly confident that this code is secure and that my private member variables, even a dynamic array, are going to be protected. But this violates that because it lets object B then go and alter this dynamic memory, which object A thinks is theirs. So this is the big problem with trying to copy objects over when one object has some dynamic memory in it. So we're going to look at copy constructors to solve this. And there's sort of two cases. One is going to be without dynamic memory. And then the other will be with dynamic memory. Now, the without dynamic memory is fairly easy and fairly well contained, and I think good to understand. So let's deal with that first. We're going to look at a copy constructor without dynamic memory. Okay. Well, our first task is, since we're creating another constructor here, well, we'll need to add this to our sort of running list of constructors that we're defining as part of this class. So here in our public goat methods, we would have our normal constructors here. And we'll go ahead and create a new copy constructor. And we're going to use goat again, except the argument for this is going to be another goat object. If we want to use one goat as a template to create another goat, well, then we're providing that source object as a parameter. So we'll need to reflect that in our code. So we will send a goat object to this constructor. And then there's our prototype. And you guessed it, we are sending it by constant reference, just as a matter of practice. Get into the habit of sending things by constant reference, sending objects by constant reference to our methods, just to make sure that they are not altered by the function. And it saves a lot of processing overhead not to have to create that separate copy if we were passing by value, and simply pass by reference, and it just sends the reference to the object. All right, well, the next thing that we have to look at is that how do we then define the copy constructor itself? So let's look at that. So here in our definition area, or our implementation file, we would have goat, just like the other types of constructors. We're just going to create a new one. Now we do know that this one takes an object, and I'll call it G as its formal parameter name. And all we do here then is we're given a source object. We just created a new target object by virtue of using the constructor. And now what we're going to do is just assign each of those variables individually. Each of those private member variables are just get copied from the source to the target. So we do know with goat that we've got private member variables for name and age and color and gender. So where do we get these values then to assign to these new private member variables in the new object we created? Well, we've got G here, and we're just going to copy all of those. Let me erase that because I just went and wrote over some code. But we will just assign this now to G.name, G.age, and so forth. So this this formal parameter name here then gets sort of passed through all of these. And that's why we'll use all of these here. And then we just unlock the private member variable, and it's going to do that direct assignment. So this is kind of the easy path for when we want to use a copy constructor. Oh, and the real advantage to this then is that down in our main program, we can simply use the much more popular encoding convention of copying one goat to another using this copy construction. So we could successfully do this. Goat 4 is going to be based off of goat 3. So this copy constructor is going to enable us then to use this popular convention. So I've got some code for that. Again, it's posted in Canvas. And let me share that now in our Eclipse. Here it is. Again, this is the case in which we don't have dynamic memory in our class. So In our list of constructors here, you can see here that I've added a copy constructor and it takes a goat object. Let's scroll down a little bit more here and look at the actual implementation of that copy constructor. And here it is right here. Again, it receives a goat object, send it by constant reference as a matter of policy and practice. If it's not going to be altered, then send it by constant reference. And then we've got the 4 assignment statements that are just doing that one-to-one copying of all of the private member variables over. Then in our main program, you can see here that I've got 3 goats declared. But then here in line 79, this is where the copy constructor is going to be called into action. It's going to create goat 4 based on the template or based on the current object, goat 3, and simply do that assignment. Then we see in our output that goat 4 here is in fact a copy of goat 3, berry female 7 spotted. So it's successfully made that copy. And of course, we'd want to go in and even though we just made a copy of a goat, now we have 2 of them that are identical. We'd want to go ahead and change that one goat's name, change the new goat to something else. So this is how again how we do it. This will help you get started with your Lab 5.3. And we're not done yet, though. We still need to cover the case where there's dynamic memory inside this class. Okay, let's next take a look at that case where our class has got some dynamic memory in it. And the most common application of this is going to be that somewhere in our class we have a private member variable rather than just being a string or an int. It could be a dynamic array of strings or a dynamic array of integers. So let's look at code that's going to support that. First, what would that code look like? Well, here in our goat class, somewhere here in our private member variable list, we could have just a pointer to a string array, easy. Here in this case, we're going to keep track of goat siblings, kind of keep a running list of if a goat has a sibling, then we could keep a list of that. Some goats might have 1 sibling, some might have 8. So having a dynamic array is going to be a very easy data structure to employ for this. And then, of course, we would want to keep an integer count of the number of siblings. And that's going to then enable us to use the array more effectively and just process the array elements that exist and not the entire array. So this is going to be what we would declare up in the class. Now, as far as the constructor, we'll get to that in a second. But since we do have dynamic memory here, we need to make sure that we include a destructor. So that means here in our public method, let me go ahead and write out what a copy constructor would look like. It's kind of the same copy constructor as before. We're going to change the implementation though, but it's going to be the same prototype. Okay, so there's that prototype. And then our destructor. Just like that. And we can easily put an inline functions for that destructor. And our 2 inline function instructions there would be, first, we're going to delete the dynamic memory that was allocated. And since we've got this dynamic allocation set up as an array, well, then we've got to include the square bracket nomenclature between the delete instruction and the actual pointer to the array. And then finally, just as a matter of good housekeeping, when you delete dynamic memory, you don't delete the pointer still exists. And it's a good idea to go ahead and reassign that pointer to the null pointer, just so you don't have this instance where we have a dangling pointer. We have a pointer pointing at a piece of memory that has since been deleted, but it's still pointing to that memory location, and that means it still has access to whatever's there. If we delete that memory location here, and the operating system can go and use it however it needs, well, our code then might actually be pointing to a memory location being used to store data for like a Word document or something, and that's bad. We don't want to have a dangling pointer like that. So we would, as a matter of practice, set that pointer back to the null pointer. So this is what how we would get started. This is what the copy constructor would look like. This is what the destructor would look like, and certainly we can create some code, a method to add siblings, and we'll get to that in a little bit. Or actually, let's talk about that right now. If we had here in our setters, if we had add sibling. There's what that prototype would look like. We're just going to throw in a sibling, easy enough. And let's look at the definition for that add sibling. Pretty straightforward. All right. And all we're going to do here is add this sibling to the array. So that's step one. And then step two, we're going to add, or we're going to increment the number of siblings that this class is tracking. So that would just be nice and simple. Since we have number of siblings, we can use that as actually an array index. So our array is named siblings. And let's say if the number of siblings is currently 0, well, then we could use that private member integer. We could use that as the index here. Just like that. So S then, the sibling is going to get then assigned to that array element at index number of siblings. And then our other job here is, since we're adding a sibling, we would just increment the number of siblings. And we can do that with a postfix incrementing there. And that's all we would need to do to add sibling. The next time around, the number of siblings would be 1. And that means that our array has 1 element in it at index 0. So that means that we can use the number of siblings here, 1, to set a new value here to index 1. And the math works out pretty easily that way. So that's how we would add a sibling. So we have the capability here of, as time goes on, having this array of siblings, and they're going to be different from goat to goat. Now let's take a look then at our copy constructor and how we would manage this. Now again, to avoid the situation where we have a goat A and a goat B, and they're both pointing to the same dynamic array, meaning they then have the same sibling list, we need to make sure that we divorce that, and that each one gets their own pointer, that gets their own array. So our goat copy constructor, oops, let me spell it right, is going to look a lot like this. All right, same thing, passing it by constant reference. G is our inbound or source. And then what we'll do is we'll do the same copying of the static member variables that we did for the other copy constructor. And that's where name is going to be g.name. And so forth. The four kind of stable or non-dynamic member variables are just simply copied over. Now we have a little bit of extra coding here. We have created, we've declared a pointer up in our class definition here. We've declared a pointer to this array, but we actually haven't created it yet. So we need to create it. So we will do siblings. We've already created the variable siblings, and the variable siblings is a pointer to a string array. So here we would just create that string array with the new keyword. And let's say that we're going to just set a constant max to 25. We would use a constant there. And you want to just create an array big enough to contain a reasonable number of siblings that will suffice for a reasonable number of goats. So now we've got one more private member variable to copy over, and that's the number of siblings. So we'll copy that over too. Because since we are doing a copy here, we are going to copy the number of siblings, and we're actually going to copy the actual sibling list over. And that's what we do in a copy constructor. Everything gets copied. But we need to make sure we're creating new memory here, and we're not going to just point to what the source's dynamic memory is. So we have to create our own new memory. Once we create that new memory, then we're just going to do a for loop and copy those elements, element by element, and our job here is done. So the very last thing that we have to do here in this copy constructor is that for loop. Okay, and since we are keeping track of the number of siblings, well, we can just use that in our for loop in the evaluate expressions, and it'll go and process that array for us. Now here, since we are in a loop, we can do that copy operation. So sibling sub I is going to equal the inbound objects or the target or the source objects sibling sub I element. And that'll take care of it. That's all we need to do. Again, anything that can be copied straight over, we do, except for dynamic memory. The step there is first, let's create the dynamic memory inside this copy constructor. And then we do a one-by-one copy using a for loop of the sources dynamic array copied into the new target or the new object that we just created to that dynamic array. All right, and then as usual, I've got some code here to share that's going to support this, and let's get that up on the screen. Okay, so here it is. This is, again, all in Canvas, and here's our class declaration, and then here's some of the code for, of course, the copy constructor prototype, but then the destructor itself. And matter of fact, to be a better citizen of our memory, I needed to add that in. We're going to reset that pointer to the null pointer. So there's that destructor. Again, anytime you've got dynamic memory, you've got to manage that memory and delete it when we're done with it. All right, so let's go down to the copy constructor itself, which is this code here, and I'll zoom in even more for this. And you see here that, I'm gonna actually move this. You can see here that these first 5 lines are just doing straight copies, all right? It's a string over here, it's a string over here, copy it. And here, copy it. We're just copying all of the native data types, nice and simple. Then in line 69, we create our objects, new dynamic memory. And then in line 70 and 71 is our for loop, where now that this new dynamic memory is created, we're gonna do the 1 by 1 copy from source to target. Well, what this does for us is it gives us the ability to use that copy constructor. Oh, by the way, here's our add sibling method that we mentioned. And you should put some guards in here to make sure that you don't overfill that array. You know, you'd want to, since 25 is our max size of the array, you'd want to make sure that you don't exceed that. And then here, you know, we see I've got the same constructor being called like we did in the last demo. But what I'm going to do here, you know, Goat 3 has got its 2 siblings of BBB and CCC. So Goat 3 has got these 2 siblings. I want to sort of prove that Goat 3 and Goat 4 now have completely separate sibling lists that we can manage separately. Yep, they sure copied. So for Goat 3, again with the siblings of B and C, we would expect Goat 4 over here also to have siblings of B and C. But I want to show that these are now different lists by now adding a sibling D and showing how that list now, or that array is going to be quite different from the other one. So here I'm going to put some code in to add an extra sibling for Goat 4, and we'll see that the lists then are in fact different. And what this is going to kind of prove to us is how the copy constructor was successful, and we have different lists that we're managing. So now here is the goat that we created. Here's Goat 3. We use Goat 3 as a template to create Goat 4, which is now highlighted. And you remember in our code, we added another sibling to Goat 4, and that's this DDD. But you can see here between Goat 3 and Goat 4, they now have different sibling lists. And this is important because it's going to demonstrate that our copy constructor worked. Elements were copied over that could or should be created, but then we've got that problem solved where we might have 2 objects pointing to the same memory location. We have solved that now. All right, so I hope that this helps explain the 2 most popular cases for copy constructors, again, without dynamic memory and with dynamic memory. And this will directly help with your Lab 5.4. So good luck and hope it helps. We'll see you later.